Periodic Motion or Simple Harmonic Motion by Caroline S. and Vivian N. Terms to know. Amplitude is the farthest distance the swing goes from the equilibrium. Equilibrium is the point where if the pendulum had stopped, all the forces would be equal. Period is the time it takes for one cycle of motion. A pendulum swings back and forth to the same height on each side. Like a hypnotist's watch, the maximum height of each swing is the amplitude. Think of equilibrium as zero. As displacement increases on either side of zero, kinetic energy decreases and potential energy increases. Total mechanical energy stays the same. T is equal to period, seconds. Length is equal to the length of the pendulum, which is meters. And g is equal to acceleration due to gravity, which is meters per second squared. The period of a pendulum equation is the period equals 2 pi times the square root of the length over acceleration due to gravity. Here's a sample problem. A tire swing has a period of 2.5 seconds. Part A. How long is the swing here on Earth? Part B. If the tire swing was taken to Mars, where gravity is 1.6 meters per second, what would the new period be? First, diagram out your problem. In this case, your tire swing is your pendulum.
For problem A, your givens are t, or period, is 2.5 seconds, your length is unknown, your acceleration due to gravity is 9.8 meters per second since you're on Earth, and pi is 3.14. And in this case, we just need to find the length of the pendulum. Use the period of a pendulum equation to solve this problem. First, plug in 2.5 for period, 3.14 for pi, and 9.8 meters per second for g. Start by multiplying 2 and 3.14 to get 6.28. Divide both sides by 6.28 so that you have 0.398 seconds on one side and the square root of L over 9.8 meters per second squared on the other side. Square both sides so that you can get rid of your square root, and then multiply both sides by 9.8 meters per second squared. 9.8 meters per second squared crosses out on the right side of the equation. Now we're going to do part B. Once again, list out your givens, which is your length equals 1.55 meters, which you're taking from the equation that you just did. Your gravity is 1.6 meters per second squared since you're on Mars now, and pi is still 3.14. And this time our goal is to find the period. Once again, you use the period of a pendulum problem. Okay. Plug in 3.14 for pi, 1.55 for your length, and 1.6 meters per second squared for your acceleration due to gravity. Once again, start by multiplying 2 times 3.14 to get 6.28. Under your square root, you can cross out your meters since, well, they're cross-outable, and then divide 1.55 by 1.6, and you will end up with 0.969 seconds squared. Take the square root of that, and then multiply it by 6.28 to get a final period of 6.18 seconds. Okay, so if you have a tire swing with a 2.5 second period on Earth, like in part A, it must be 1.55 meters long. And if you took that same swing to Mars, like in part B, its period would increase to 6.18 seconds.